We're going to try these problems. First, f of x equals 1/4 absolute value of x. So the original defining points are -1, 1, 0, 0, and 1, 1. So this is kind of what our absolute value graph looks like, generally speaking. Now this 1/4 is a vertical stretch. It's actually shrinking it because it's going and multiplying all the y values by 1/4. So this is doing something to the y values. So that means the transformed points are going to be -1, 1/4, 0, 0, and +1, 1/4. So that means our new graph is going to look something like this. Now, it's important to understand that -4, 1 and 4, 1 are on the graph, but that's not what happens to these points. So these defining points got moved in a vertical stretch type of way. Number 2, this is, it looks like we have a square root graph that has been moved to the left 4 and up 1, but it's still growing at the regular rate for a square root graph. So this is going to be y equals the square root of x plus 4 plus 1. Remember that this is a horizontal shift, and horizontal shifts are basically, they look the opposite of what you see. So you see the plus 4, it's going to go to the left 4. And then this one's the vertical shift right there. So let's go a little bit more in depth on problem 1 on the answer. This was what we talked about. Why is it not this? Well, this particular graph looks exactly the same. And actually, if you were graphing this without talking about the points, you probably wouldn't even notice a difference. But remember, this is a vertical stretch. And this one over here moved the x values, which means that the function that we're talking about here, g of x equals the absolute value of 1/4 x. Now notice that these are basically the same thing in terms of what we in our brains would kind of think about. We're taking the absolute value and then we're multiplying by 1/4, or we're taking 1/4 of some number and then we're taking the absolute value. For us, that wouldn't really make that much of a difference mentally, but it's actually making a big difference in terms of which points get moved where. So on the initial graph, that looks something like this. I didn't draw that very well, but on the initial graph, this point gets moved down, this point gets moved down, 3, 3 gets moved down. Whereas on this graph, this one I'll try and draw a lot better. On this graph, this point gets moved out. This point's getting moved out to 2, 8. So what's ending up happening is that the graph ends up looking the same, but the way that the graph gets there is very different. And this is something that we didn't talk about very much in Honors Pre-Calc or in Honors Algebra 2 Trig, where we were doing horizontal stretches, but we did talk about it during the trig unit. So when we had something like y equals sine of 2x, what you noticed about the period of that function, the normal period of sine of x is 2 pi. But then when I have sine of 2x, the period actually shrinks. The period gets divided by 2. And so what ends up happening is we're taking this number and we're dividing the x values by whatever this number is. So notice that this 1 did not get multiplied by 1/4. It got divided by 1/4. So 1 divided by 1/4 actually moves it to 4. So this number, even though it's smaller than 1, is actually stretching our values. Whereas in this sine graph right here, that was shrinking our horizontal, our x values. So if we look at the function a absolute value bx plus c plus d, or any kind of function that's some kind of f of x, we have these situations going on. A vertical stretch, y values are getting multiplied by a, or a vertical shift, y values are getting moved to the right by d. Whereas B and C, the horizontal stuff, actually works backwards of how our brains think. So the x values in this case are getting multiplied by 1 over B, and the x values are moved by the opposite of C. And so that's something that we learned last year, but we're just kind of reviewing right now. Now, transformations with all four. Let's kind of look at what would happen in each of these cases and which one's correct. So this function is the absolute value graph. And then what we're going to do is we're going to do some shifting. So what happens if we stretch vertically by 2? So that means our slope now is basically 2 and negative 2. So we do that first. Then we shift down by 3, and then we move left by 1. So down 3, left 1, and the slope has become 2, so to speak. Versus moving everything down first. So move it down, and then multiply all the y values by 2. Well, if I do that, what's going to end up happening is this point would then get moved down, and these points on the x-axis would not change because y equals 0 wouldn't change at all. So then our second thing would look something like this. And then our third thing would be finally moving it to the left 1. Notice these two graphs are not the same. So if I stretch first, then move down 3, then move over 1, that's not the same as moving down 3 first, then doubling it. Like this is at a y value of 6, whereas negative 6, whereas this is at a y value of negative 3. So these are definitely different. The order matters. So when we have y things, we do the stretching first and the shifting second. So this happens first, this happens second. This is how we do it. If it's horizontal, we actually go in the opposite direction. So if we had this, we would do left 4 first, and then multiply by 1/2 second. Okay. The other thing is last year when we were doing phase shifting and we were doing horizontal stretching, or period stretching, what we would end up doing was we would factor out this 2. So we can do this in two different ways. So we can say f of x equals negative, and then we have 2 times x plus 2 cubed plus 3. You can do the factoring out of the horizontal changes like we did last year. In that case, you would treat horizontal stretches first, or in trig functions, it was period changes. And then you would do the shifting after that. Or you can do method 2, where horizontals go in the opposite order of everything. So basically, the +4 means left 4. The ×2 means divide by 2. But you would also go in opposite order of the way that we normally think about it. So you would do the shifting first, and then you would do the stretching or shrinking second. This I can demonstrate on Desmos pretty fast. So we're going to start with our parent function y equals x cubed. Then I'll deal with all the y stuff first. So we're going to reflect it over the y-axis. Reflect it over the x-axis. And then we're going to do a vertical shift of 3. So now this is kind of what all the y stuff does. Method 1 was factoring out the 2. So we would then multiply all of the x values by 1/2. So notice what happens to each x value. This 1.4-ish goes to 0.7. So all the x values get divided by 2. And then we're going to move all of those to the left 2. So notice we end up over here. So notice what happened. We took all of the x values divided by 2 first, and then subtracted 2. But if we did method 2, all the y stuff stays the same. Then I would subtract 4 from the x values first, and then take every x value and multiply it by 1/2. So notice that 4, 3 turns into, negative 4, 3 turns into negative 2, 3. All of the x values then, after you move them to the left 4, then you take whatever the x value is and multiply it by 1/2. One more example. We can use method 1, and the y values I'm going to assume we understand. We multiply by 3 and then subtract 1. So I'm not going to spend too much time on the y values. But the x values, we can do method 1, which would mean factoring out the 1/2, which means we divide by 1/2 or multiply by 2 first, and then subtract 6. So multiply by 2 gives me negative 2, subtract 6 gives me negative 8. And same, 0 times 2 is 0, minus 6 is negative 6, 1 times 2 is 2, minus 6 is negative 4. Or we can leave it unfactored. We would subtract 3 first and then multiply by 2. So negative 1 minus 3 is negative 4, times 2 is negative 8. 0 minus 3 is negative 3, times 2 is negative 6. 1 minus 3 is negative 4. 1 minus 3 is negative 2, times 2 is negative 4. So either of these methodologies will work in terms of doing horizontal stretches and shrinks and shifts. It just kind of depends on which one you're more comfortable with or which form it's in. You can now do it either way.